Dana Golden. Here we are at NREL's website. Hopefully, one day I'll be working on it in some capacity. You can tell that as a grad student, this is something I think about a lot. And you can see these lovely scenarios. They have a scenario for electrification. You can change it to the reference level. This is like what electric energy consumption is going to look like in the reference level. Let's do transportation, because that's a sector that's really affected by the expectations. Is expected to rise a lot over time, and that's based on the idea that we're electrifying the fleet. And then let's say we want a higher level of electrification. We want the highest case. Then it moves to electric much faster, and then here we're using substantially more. Here it's BTUs, some amount of BTUs, and we're using substantially more by 2050. So there's different scenarios for electricity. We can also do this by particular state. So let's see for Georgia what's expected, and then we can do that. We can add on different things. This is I show you how to create visualizations like this. I talk about it in the dynamic visualization class, which I encourage you to take seriously, because this is something that I think a lot of people really like in industry. You can also have the data viewer. Here's the localized cost of saved energy, which essentially maps onto how much energy costs in a particular place. Localized avoided cost of energy, what we call in this class. You can see that in New York, the cost of energy is pretty high. Up here in New England and then the Midwest, because there's a lot of renewables, energy is dirt cheap. Tennessee does not have one because Tennessee is a vertically integrated utility and doesn't release these statistics. I think that's why Tennessee doesn't have one. They should have this data for Puerto Rico. They don't have great Puerto Rico data mostly, and that's very unfortunate. I'm not going to get into it, but if you're ever creating a data set, please add Puerto Rico. That is for the entire United States. Make sure you add Puerto Rico, Alaska, and Hawaii, because it's very important to have the good data so that we can make policies that work for people who live there too, because those are also parts of the United States. And it's legally required for every statistical agency to do it, but a lot of them have trouble. And it's not their fault. It's just hard to get data for Puerto Rico quite often, which is unfortunate. So here I've blocked off everything but solar and wind. So I can, when I do this, I can block off things. And so you can see what the LCOE is for different types of power. And then in most of the country, land-based wind is the cheapest. And then some places, solar is the cheapest. Georgia, where I'm from, is a very sunny place. California is a very sunny place, so utility photovoltaics is pretty cheap. Everywhere else, wind is a very cheap power, and that's amongst solar and wind. What happens if I change to hydro? Everything is hydro. Hydropower is an extremely cheap source of energy, but it's hard to add. If we add combined cycle natural gas, if we add combined cycle natural gas, you see that most places combined cycle natural gas is the cheaper, and then some places have land-based wind is the cheaper. Interesting enough, let's unfilter everything here. No, we don't want to unfilter everything here. We want to unfilter, I should say, everything except the solar and wind. Let's unfilter this gas. So now this is just solar and wind, and you'll notice in some places land-based wind is cheapest, and some places utility level PV is cheapest. But what happens if we go to 2050? So this is what we expect the lowest cost of energy to be decades from now. And notice Maine, Massachusetts, offshore wind has gotten a lot cheaper. Here where we are in New York, offshore wind is almost cost competitive with land-based wind and is cost competitive with utility photovoltaics. Even in Georgia, offshore wind is the cheapest, and then most of the rest of the country, it's the second most expensive, or second cheapest compared to land-based wind. Though obviously not putting offshore wind out here in Kansas. It's not even offered because where would you put it? And you can do this also at the county level, so you can get much more granular level data on the cost of different energy sources, and you can download this data. I don't know if it's going to show it. If it doesn't, just know right now I'm showing a spreadsheet of counties and different costs that you can look at on this page. And then data library, you can look at all sorts of different scenarios. You can look at different variables here. High renewable energy cost scenario. What energy will look like by 2050. If you have high renewable energy cost, and then you can have maybe there's high demand growth, which is what a lot of people are worried about right now. So now here's the cheapest technology by 2050 if demand growth grows quickly. Nuclear, I love the Georgia nuclear. High demand growth. Georgia has been Vogel, go Vogel. And then in New York, we're also traditionally a pretty big nuclear state. And you saw this, of course, with decommissioning of several reactors. We still have some pretty significant reactors up in New York. Most of them are upstate. And then, yeah, you can play around with this. You can see what's going on with offshore wind and what the costs are across places. And yeah, this is Slope. It's a really great tool that you can use to analyze data. And yeah, I really hope you spend some time playing around with it, and I hope you have a great day. Thank you.